All right, we're going to continue our talk with about circles. Let's see, what did I copy last time? Oh, good. Circle's still there. Let's make this a little bit bigger because I'm going to draw some stuff inside this circle. Oh, why does it do that? I don't know why it does that. Oh, my goodness, what's going on? All right, let's just come over here and just grab it. I don't know why it makes that big square like that. I'm not sure what I'm doing to make it do that. Alright, let's make this circle pretty big. That's pretty big. Is that big enough? Alright, so what we're going to do is we're going to draw some lines in here. And we'll go orange. And let's see what I want to do first. Okay, let's do this first. We're going to draw two radii. It doesn't have to be completely, horizontal. It doesn't make any difference. But I'm going to draw two radii. And what did I just form right here when I drew those two radii? An angle. Right. Made an angle right there, didn't I? Okay. That angle right there, where is the vertex of that angle located? At the center of the circle, or at the center, yeah, it's the center of the circle is the vertex of the angle. Right? So we call this the central angle. Alright, so that's what we named that angle right there. So right now that doesn't really mean anything to you, so we named it big deal. Okay, what we're going to talk about is this. Do you see where it hits the circle right here and it hits the circle right here? Let's make this a little bit thicker. If I can trace along the circle, this isn't that easy. But ooh. So watch this. I traced along that circle right there. It's a little squiggly there, but you get the idea. You see that thing right there that I just traced? We call that an arc of the circle. And that's pretty important. We're going to deal with this a lot. Really, the rest of this chapter, we're going to deal with this kind of stuff. All right, so that is an arc. And an arc, well, what is a degree measured in? If I was to measure this, I'm sorry, I just gave it away. I said degree because I'm thinking of the answer. What is an angle measured in? In degrees. Thank you very much. Okay, so an angle is measured in degrees. Guess what? An arc is measured in degrees as well. Because you've seen this before. Like in basketball, they talk about this, like a 360 dunk, right? You've heard about that. Skateboarders use that. The snowboarders and the skiers, and they talk about that all the time. Oh, he did a 540, or he did a whatever. I don't know what the numbers are. 620, is that what it is? Okay, 720, yeah, whatever. Did a 720. I can't believe it. And all that kind of stuff. Well, what are they talking about? They're talking about angles, and they're talking about how far around the circle they went. If you do a 360, how far around the circle did you go? You went all the way around. Okay, that's 360 degrees. What if you only went halfway around the circle? What'd you do? 180. You ever hear anybody talking about their life and, God changed my life and He turned my life around 360 degrees? Right. That means you're doing the same exact thing as you were doing before. They didn't really mean to say 360 though, did they? What did they mean to say? Right. They meant to say 180. So every once in a while you'll hear somebody say that and it's kind of humorous. I don't say anything to anybody about it. I just kind of giggle to myself. Well, I don't giggle, okay, but I kind of snicker. I do snicker, all right? So I don't giggle, but I snicker. So anyway, so it's 180 degrees. So look, around this arc, you measure an arc in degrees. If I measured the whole entire circle, it would be 360. If I measured halfway around, that would be an arc as well, because I go from one point on the circle to another, that would be 180 degrees. What if I went completely straight up and down? What do you think that would be? It'd be 90 degrees, okay? So we measure an arc in degrees. Everybody understand that? Now this is what's cool about the central angle. The central angle, whatever that angle is right there, I don't know, let's say it's 70 degrees. Kind of looks close to 70. Whatever the central angle is, the arc is going to be the same exact number of degrees. All right? So the central angle is equal to the arc that angle cuts off. And that's how we say that all the time. We say it cuts it off. So it starts here, it hits right here, and it hits right here. It cuts off that arc right there. Does that make sense? So the angle and the arc are the same measurement. So this arc would be 70 degrees as well. Let's put a couple letters here, and let's talk about this. What would I name this angle right here? What would this... It's a central angle, but what would I... It's ACB, right? This is angle ACB. All right? But the way we measure an arc is you just use two letters... the endpoints of that arc. Okay, so it starts here at A, it ends at B, or it starts at B and ends at A. Right? Those are the two endpoints of the arc. So I'd call this arc AB. And again, we have a symbol for this. And the arc looks like this. We put a little half moon thing over top of it. Okay, that's the symbol for an arc. So when I talk about an arc, That's what we use right there. You could also say arc BA. It doesn't make any difference. All right, it's not a very nice arc, but you get the idea. It doesn't matter where you start or end. That would be arc AB. So if this is 70 degrees, then the arc that it cuts off is 70 degrees. Now, they're only equal to each other when this is what kind of an angle? A central angle, okay? The central angle means that the vertex of that angle is at the center of the circle. That's the only time that the angle is equal to the arc. Everybody see that? Because not today, but another lesson, we're going to do some other angles inside the circle that the angle is not equal to the arc. All right. On this case, though, this is the easiest one. This is where the central angle is equal to the arc. Are we clear on that? Okay, good. Let's see what else they do here. All right, I'll tell you what. Let's do this quick little example. I think we can do this pretty fast. Let's copy that. And let's paste it. And I'm going to put some stuff in here. Let's go like this. Let's go like this. This is an example that they have in the book. This is straight from the book. And let's say that this goes about like that. Alright? And let's label some stuff in here. I think they make this 130 degrees. Actually, I didn't want that blue. Let's keep that white. Okay. And let's make my writing blue. And this is a right angle right there. And they ask to find that angle. Alright, so the arcs really have nothing to do with this, but this is pretty easy. We just talked about this. What is it all the way around? 360. Like, so watch. Even the angle, right? Right there. That's 360 degrees, isn't it? Make sense? Alright. So if this is 130 and this is 90, what do I do? What's my math involved to find what x is?
360 minus 130.
Yeah, 360. This is what I would do on the calculator. Okay, I would just go 360 minus 130, what? Minus 90. That's what I would do in the calculator. Alright, and you could probably do that in your head, but we'll punch it in. 360, gotta turn it on. 360 minus 130 minus 90, and that is 140. So that's what this angle is right there. It's 140 degrees. Now watch. I don't even know if they ask you this. They don't. But what if I asked you for arc AB? What would arc AB be equal to? 140, exactly right. So arc AB is 140 degrees. Make sense? Okay. Let me just say one more thing. Yeah, they do talk about this, and we'll talk about this right now. If I did this, watch. Let's extend this all the way to here, and let's call this C. Yeah, we'll call this ABC. We'll call this D. All right, that's good enough. Look at AB. AB is less than 180 degrees, isn't it? When you have an arc that's less than 180 degrees, that's supposed to be an E. Oops, can't spell. Less than 180 degrees is called a minor arc. A minor arc, we just use two letters like we've done right here. Okay, so AB is a minor arc because it's less than 180 degrees. If you have exactly 180 degrees, what arc would be exactly 180 degrees here? CB, right. It's either this arc or this arc. The problem is, how do I know what arc I'm talking about? They're both 180 degrees, but if I say CB, am I going this way or am I going this way? I don't know, do I? If all I say is CB. So what else do you think I could throw in there to figure out, let's say I just want to talk about this arc on the left, this 180 degree arc on the left. What do you think I could call it? CAB, that's right. So if I go 180 degrees or bigger, I'm going to use 3 letters instead of 2. Right? 2 letters indicate that it's a minor arc. Right? So I wouldn't say this. If I said arc AB, I know I'm talking about from here to here. I would not be talking about from A all the way around to B. Does it make sense? So if I just use 2 letters, I'm going the shortest distance around the circle from A to B. That's 140. Everybody got that? Okay. So if I wanted to talk about arc CB, this one on the left-hand side, I would call this CAB. You would just use 3. Now, I could have other radii come in here and having a whole bunch of other points here. You could use any point that's in between. For instance, if I had an arc or a line coming right here, a radius coming right there, and I called it E. I could call this 180 degree arc, I could call it CEB. Do you see it? Or I could call it BEC. Or I could call it what? BAC. Do you see it? You got all kinds of different options on that. And we've done that kind of stuff before as far as having different options on what to call it. So that's what it would be. Now, if it's exactly 100 degrees, so we said less than 180 degrees is a minor arc. If it's exactly 180 degrees, then we call it a semicircle. All right? All right, so it's a semicircle if it's exactly 180 degrees. I'm a little disjointed with my notes here, but you get the idea. So less than 180 minor, exactly 180, we call it a semicircle. So guess what? What if it is what? What if it's greater than or more than, we'll say greater than 180 degrees? Absolutely. If less than is a minor arc, what do you think greater than is? It's called a major arc. Okay, and a major arc, we use 3 points to talk about a major arc. So let's do this. Let's talk about, let's go from C to E, but let's go the long way around. Let's go this way. Everybody watching? So if I start at C and I go all the way around to here to E, I wouldn't just call it arc CE, would I? Because arc CE would be the short distance from here to here. That would be a minor arc. If I want to go the long way around, what could I call it? I could call it C, a couple things. C what? C, I could call it CDE, right? Arc CDE, or what else? CBE, right? I could go backwards too, couldn't I? Right? I could go EBC or EDC. You follow me? No, you're not going to use all 4. You're only going to use 3. All right? You only use either 2 or 3. Don't put all of them in there. All right? So you either go 2 or 3. If it's a minor arc, use 2. If it's a semicircle or major arc, you use 3. All right, enough of that. We need to move on. Running out of time. I told too many ping pong stories today. I gotta. Let's do this real quick. What if we talked about circumference yesterday, didn't we?
Yeah.
But that was the distance around the whole entire circle. Agreed? What if? I'll just make a number up. Let's say, what does that look like? 100 and let's say 130. Okay? Let's say it's 130 degrees. It's probably closer to 150, but that's okay. We'll say 130 degrees, that angle right there. So what would arc AB be equal to? 130 degrees, okay? So that's easy, right? You can find the measure of the arc. So arc AB is equal to 130 degrees. What I want to do, and let's put a radius in here. Let's say the radius is 5, okay? What I want to do is I want to find the distance around that arc. Oops, let's go to about, make it real thick. All right, so if I go from here, oops, oh, doggone it. Anyway, you get the idea. I'm not a very steady hand. Good thing I'm not a surgeon or something. All right, you get the idea though. This arc right there, I want to find the length of this arc. So if I took a piece of string, bell's going to ring in a second. Just hang on for a second, okay? If I took a piece of string, wrapped it around the circle, I want to find the length of that line right there. Okay, so how do we do that? Well, you know what the circumference of the whole circle is. What is it? It's 2 pi r, correct? But we're not finding the distance around the whole circle. We're only finding the distance of a chunk, a part of the circle. How much of the whole circle are we trying to find? Half of the circle? More than half? Less than half? What? Okay, but how much out of the whole circle? 130 degrees. So watch. This arc length right here, okay, so if I said, we'll just put it equal. It's, watch, it's 130 out of how many altogether? No, 360. It's 130 out of the whole entire circle. Okay? You follow me? The whole circle is 360. But we're only finding what? 130 degrees out of 360. Then what do? 2 pi what? R, which is 5. Look, I'm not going to do this because the bell just rang, but throw this into your calculator and just guess what you got. You found the length, and this is what they do, the length of arc AB. All right? So there you go. Now watch. I probably won't talk so much in my 7th period class about other stuff. So if you want to look at the 7th period video on YouTube, go ahead and do that. And I might get into a little bit more detail on that and maybe give another example or two. So if you really want to get a little bit more. But I pretty much told you everything you needed to know today. So here's what we're doing. We're doing numbers 12 to 23 and 26 to 41. Okay? And that's section 10.2. You can find the pages. Okay, it's section 10.2. Just look at section 10.2. Sorry. Go to section 10.2. Go to and do those numbers right there. Okay?